Hope everyone's having an all right day and surviving the heat well enough. We'll go ahead and get started. So thanks for making time to join us for this webinar, which is going to be focusing on that transition from Key Stage 2 to Key Stage 3 in science. We've been thinking a lot about this year, transition and how we can support that. So we're really pleased to welcome Ashleigh Morse, who is a National Secondary Science Lead. She has over 12 years of experience in science education. I know she really specializes on turning curriculum and assessment policy into really practical classroom strategies. So today, Ashleigh's going to share insights on how to support that really smooth and effective transition from Key Stage 2 to Key Stage 3. And just before I hand the mic over to her, a bit of housekeeping. There is a Q&A box, which you should be able to get to at the bottom of your screen. Please submit questions throughout the session. We'll make time to answer those at the end. So make use of that. And this session is also going to be recorded, and we'll email you the recording afterwards, which you'll be very welcome to share to any colleagues who are interested. So I will pass the mic over to Ashleigh now.
Thank you, Constance, and thank you for the introduction. Hi, everyone. I will start by thanking you for joining this session this evening on supporting Key Stage 2 to Key Stage 3 science transition, an area that, honestly, the past sort of 3 years, I've had the grace to explore in much more detail than I had when I was full-time classroom teaching. So I'm excited to hopefully give some actionable takeaways, or at least some discussion points throughout this session. In terms of contents, we'll start by having a look at the importance of transition, why we're really zooming in on transition. I'll then share what I like to call the hidden depth of Key Stage 2. And it's just some areas where, as a secondary science teacher, I was surprised by the depth that Key Stage 2 went into, and I'd like to share that with people as well. We'll then have a look at how we can preempt misconceptions that carry through to Year 7, before looking at an intellectual Key Stage 3, or what I like to call an intellectual Key Stage 3, how we can build on the misconceptions from primary and the depth of primary to inform our planning, before handing over back to Constance for some reflections in Q&A. So I'll begin with why transition matters. And I'm starting with a quote from Ofsted from the Science Subject Report 2023, which I'd argue is still very current. So the quote is, "Plan the secondary science curriculum to build on what pupils learned in primary school and not simply repeat it or assume pupils learned little." Now, this report was sort of collated and carried out from as early years all the way up to Key Stage 5. And one of the things that Ofsted found during this study was that often Year 7 feels like reteaching when they looked at the curriculum across all the different schools that they went into. Although it was broad, it started with these topics that were called introductory topic 2, and then it proceeded to be something that was in the Key Stage 2 curriculum. So that was really interesting. And with that in mind, I just think it's important to point out that Year 7 should represent progression, not just a restart. I think that as Key Stage 3 teachers, sometimes we think it is a little bit safer to start from scratch with everybody. Although I'd like to acknowledge that COVID-19 did mean that was probably necessary. Before that and now, we're able to treat Year 7 as progression and not go back to restarting. So the tables I'm about to share with you is information, again, taken from Ofsted findings around sort of the assumptions we as secondary teachers, sometimes, not always, have about primary education. And I will be absolutely honest, like I said at the start, I didn't really have the grace to delve into this as much as I have until the last 3 years. So some of these assumptions I, hands up, did have myself. So we have pupils arrive with limited science knowledge. Year 7 needs extensive reteaching, and primary science is mainly descriptive. What I can tell you from the Key Stage 2 national curriculum, the Key Stage 2 national curriculum, and what I have seen since working closely with Key Stage 2 science leads, is actually pupils do encounter biology, chemistry, and physics, the foundations of it, substantially before Year 6. Many foundation concepts are introduced before this, And also pupils engage with classification, observation, explanation, inquiry, very hands-on, lots of experimental work where they're not just observing and describing what happens, but they're actually recording the data. So lots of parts of secondary science, particularly what we would call working scientifically, has been introduced earlier on in school. What I do want to add to this that I think is extremely important, and it was only brought to my attention in a very recent meeting, was that although I am saying pupils do have substantial science knowledge, often at primary it might be called topic or categorized under what is known as topic. So you may ask a pupil, have you done science, or what have you done in science? And their expression might give you the impression that they don't really know. And it's simply because it's perhaps branded as something else. So you might want to delve further into that and give specific, more focused questions opposed to just asking them about science. Now, the flowchart that I'm going to share with you now, I like to call it the domino effect. And this is just a representation of how us potentially reteaching could cause a larger issue across a long period of time. So if we have weak curriculum continuity from Key Stage 2 to Key Stage 3, we are very likely to repeat prior learning. If we repeat prior learning, which, as I said, I do think I've been guilty of, and I see lots of curriculums where we do these introductory lessons, as Ofsted have pointed out, this reduces the challenge. Our students then feel this lack of engagement. I know that they often come to us after an open day where we're showing all the experiments we might do, and they're really excited for that. And then we're like, let's reteach you what you already know for a few weeks. That can lead to slower progress. If nothing else, it's not just because there's a lack of engagement, but the time. We know that the science curriculum is huge, and one of our big struggles is fitting it all in. So if we spend a month, 5-6 weeks teaching or reteaching the foundations, that's taken away from where we could be really going into more complex science. And ultimately, it can, but not always, lead to a greater disadvantage gap. I like to sort of focus on science capital, and if science capital is not a term that you're familiar with, I would write it down, make a note of it, and have a look at it at your leisure. Science capital is more about relationships with others, experiences out of school, sort of the passions of people around us, those that we're socialised with in terms of a STEM or science focus, because we know it's not just down to us as teachers. A student may live in a household where their parents are from a science background or work in a science field. They may go to museums. They may even just watch, Attenborough on telly with their caregivers. And the reality is that the higher attaining students usually are the ones that fall into that category, the ones that have greater science capital out of school. So while we're repeating the same content, those students are still learning more out of school than perhaps the disadvantaged students. And unfortunately, the reality is the gap is often getting bigger. This is my favourite part. It was quite shocking to me when I started working with primary specialists at how much the primary students did know, especially at Key Stage 2. So I've just zoned in on 2 areas, but I will verbally tell you a few others where I believe it goes into great depth, the Key Stage 2 curriculum. So to embed an intellectual Key Stage 3, we need to understand what our pupils have encountered before they arrive to us in Year 7. The first area I've chosen to focus on is rocks. A primary curriculum might ask the pupils which rocks are rough, which rocks are shiny, how are rocks formed, and by that I mean that they're formed naturally, they're not man-made. Which rock could be slate? You see now that primary pupils are taught to identify some more common or easily identified rocks. Which rocks are dull? How could you describe these rocks? What is the same about these rocks? And which rocks could be granite? So our students come to us having looked at this at least once. So this is a topic that is in the national curriculum at primary. So when they come to us, they probably know, providing they're able to recall the information, that rocks are naturally formed. This particular rock is dull, has holes in it, is rough, has no layers, and is pumice. To point out, some of these are more important than they perhaps seem at first glance. Knowing that this rock has no layers and has holes is really going to feed into us building on this when we teach specific rock types in more detail. So in purple, I've highlighted what they bring to us in year 7 from primary. So this rock has holes, this rock is a pumice. We're going to build on that and explain how the holes are formed. This rock is an igneous type of rock formed when lava cools, can often float on water due to being less dense than water. So we had a good starting point on the previous slide of things that our students should know. And here we can see how to build on that. I'll admit I probably would have spent a full lesson on each type of rock, thinking that my students were unaware of even the basics. But now that I'm aware of what they did learn at primary, I think that with a mid to high attaining group, I could probably do all 3 rock types in one lesson. And then the next one, lots of recall, lots of retrieval to check it's really stuck before then going on to the rock cycle. We also have states of matter in key stage 2, so solids, liquids and gases. Now, something that I think is so important to acknowledge as a teacher or an educator of any sort is that we're allowed to change our minds, and research is ever evolving. I remember once looking at a curriculum that another school delivered where they had 1 lesson per state of matter in year 7. So a lesson for solids, a lesson for liquids and a lesson for gas. I remember thinking that was revolutionary. It was so great that they had the time to offer that and go into this really, really sort of zoomed in detail for each one. It wasn't until years later when I was able to look across primary and secondary curriculums that I realised they already learned all that at primary. So a primary curriculum might ask students or pupils which state can freeze, in which state are particles closely packed, which state can condense, what are the 3 states of matter, which states flow, which states can melt, and in which states do particles vibrate. Again, that is a foundational set of knowledge that actually we can just spend a little bit of time revisiting and not reteach. So when they come to us in year 7, a student might already know. And please notice that although I am praising the Key Stage 2 curriculum and really hoping to open our eyes to the breadth that our students have when they come to us, I use the word might quite a lot because I'd hate to make assumptions that every single student has been in school that day, retained that information and is able to recall it. But the majority should have come across this before. So might already know that this is particles of a solid. The particles are closely packed. They're arranged in a regular pattern. The solid will keep its shape and particles vibrate on the spot. Now from that, we don't need to reteach that this is a solid in a regular pattern with particles that vibrate. We need to add to this that this has low energy, there are strong forces between the particles, and it has high density. So like before, in purple, I've highlighted the foundations that our students should come to us with following the Key Stage 2 curriculum. So let's have a look at preempting misconceptions. Now, by misconceptions, I mean a student has potentially been taught something in a more basic way, which is absolutely okay. I know as scientists sometimes, or as science teachers, we really fixate on things being really accurate, but the language used at Key Stage 2 is developmentally appropriate for those young people. It provides a strong foundation on which to build a student's mature and gain life experience. So it might make complete sense for a teacher to say to 39-year-olds, a plant makes its own food. That's why it doesn't have the organs in order to eat and digest. Opposed to us at secondary, giving the word equation for photosynthesis and explaining that in depth, and then even at higher key stage 3 or 4 going into the symbol equation, that would have the same problems as us reteaching. That would be too difficult and students would lose engagement. So what we need to do as secondary educators is take this breadth of knowledge and change the vocabulary, use models like the example I just gave for photosynthesis, such as word equations to describe a system or a process. And semantics. So has something been said in a way that is the simplest form so that a young person is able to understand it? Can we use that to our advantage? Use that the first time we say something, see who has heard that and understands it, and then change the language to be more appropriate and more accurate. I thought I would pick out some areas that I think, just from my own experience, this is not from a particular area of research, students when they come to year 7 have misconceptions around, or not even a misconception, but are using the incorrect language for GCSE. So we have breathing and ventilation, talking about things being heavy and associating that with weight, energy being used up opposed to energy transferred, electricity flowing, and we will then introduce current and charge, and a dissolving substance disappears opposed to a solute remaining. And I'm going to focus on just one of these areas. I'm going to focus on energy. And I want to really remind everyone of what I said earlier about the language that is used at primary is appropriate for where those students are developmentally and their life experiences. So we're going to build on that now when we introduce energy at Key Stage 3, but we're not going to reteach. We don't need to go right back to the very beginning. So a primary curriculum might say, some energy in the battery is used up. So a young person or a child probably knows that when something is battery powered, the battery runs out. We use the thing so many times, the battery runs out. It's great that they know that's a form of energy. There's energy in that battery. It's used up as the device works. They might also say the battery's energy level has gone down. Again, great starting point, not completely accurate, not the language we want to use, but we're going to start with it. We're going to use this misconception to our advantage as we introduce the more advanced vocabulary. And we can say the chemical energy store of the battery decreases as energy is transferred electronically to the motor, increasing the kinetic energy store. Perhaps I would break this down into different chunks. The very first part, the chemical energy store of the battery decreases, is almost what they know. We just need to specify stores and teach the students the stores. But once they've got examples of different things in each store, they get it decreases as some of it is used, and then we can introduce it's not used, it's transferred. Probably have an understanding of what the word transfer means as well, just from day-to-day life. Another quote from Ofsted, this one is from the Science Research Review from 2021. Curriculum plans consider how component knowledge introduced at one point in time influences future learning. This ensures that knowledge builds incrementally from pupils' prior knowledge. So with that, or by that, I mean that we can probably preempt many of these misconceptions. In fact, anytime I ever speak to any science teacher of secondary and I say, can you tell me a misconception? I'm pretty sure they say the same ones every time, which were mainly the ones from the table. I'd be interested if anyone's got any they want to contribute, even if you just write it in the Q&A and I hear it later. But yeah, I'd love to hear more that I've missed. So let's have a look at an intellectual Key Stage 3. And by this, I mean, let's use what we know. We can only do the best with what we've got. And I know that our time is a huge limiting factor. We don't necessarily have time to have the relationship we want to have with our feeder schools, but we can do the best with what we've got. So my advice would be to, as a team, as a science team, for upcoming units, highlight what is covered in Key Stage 2. Hopefully, I have gone through some of that with you earlier, such as rocks and the particle model. I will add another one that I was pleasantly shocked by was the heart and the detail that students go into about the different blood vessels. I didn't know that was something at Key Stage 2. And when I did, I thought, wow, I have definitely spent an hour reteaching all of that when I could have just done some recall activities so that they remembered it and then moved on to something more advanced. So highlight what's covered in Key Stage 2 for upcoming topics. Don't go away and read the whole Key Stage 2 national curriculum because you're probably not going to remember it at the right time. You can just press Control and F on your keyboard and search the word of a topic that's upcoming and it will highlight that for you. Then as a group, discuss preemptive misconceptions. So amongst you, you'll have a wealth of experience, different years in different settings, and you'll be able to just say, well, this was a misconception that I've seen. And a few people will offer other ones. And from there, you can set some diagnostic questions. I know that some schools like to give the students a base test when they first start. I do think that that has its limitations as well as its huge advantages. I would probably, as I said earlier, spend a little bit of time making sure the students know what is science opposed to topic before I start quizzing them on things. Maybe give it another couple of weeks before you do that, but absolutely get some diagnostic questions together and agree on an appropriate vocabulary upgrade so that every teacher in your department has got the same sort of starting point of, right, these are the misconceptions my class may have. These are some questions that will really help me to pinpoint those in a really low stakes way. I'd probably use mini whiteboards, A, B, C, D, and then I can quiz my class and just get a sound understanding of what they can recall like that. You don't want to know every topic, you just want to know the foundations. At Key Stage 2, as I've already said, sometimes the vocabulary feels quite simple, but I think that we also do this at Key Stage 3. Sometimes we use language at Key Stage 3 which is developmentally appropriate, such as making new cells instead of mitosis. Okay, pre-diagnostic questioning. So I've just spoken about how we can use questions, having met as a team to come up with misconceptions. We might then come up with questions to ask our students just to see if they've got those misconceptions and the language we want to use to build on it and make it more accurate, more factual, more scientifically correct. So we might choose to be quite open-ended. So I've got a couple of examples of these. What happens to food inside your body? You might ask a student cold call. You might ask them to write their answers on a mini whiteboard, but just in bullet points. You might ask a few students and get them to build on each other's answers. You might ask a student and ask another one if they were right or could they add to it. Use your autonomy. We do love a bit of teacher autonomy. Some preemptive misconceptions could be that food is energy. Food either goes to our stomach or leaves the body as waste, and that teeth are solely responsible for chewing food to make it smaller. Now, they're not completely wrong. They're not shockingly wrong, and we think, wow, I need to completely go back to the drawing board. You can actually see the use of these misconceptions. So, as a team, we've met to have a look at what the misconceptions may possibly be, and I've highlighted and I've made bold a vocabulary upgrade suggested from these misconceptions. So, food is broken down into smaller molecules used for a chemical process that releases energy. So we've gone from food is energy, great starting point. Well, it sort of is, but it's broken down into smaller molecules that are used to release energy. The middle one, food goes to our stomach or leaves the body as waste. Well, they're correct. The food does go to our stomach and it does leave the body as waste. However, there's much more to it than that. Food contains nutrients that are absorbed into the blood and used by the body. And again, that links to the point above it. They're used for chemical processes that release energy. And teeth are solely responsible for chewing food to make it smaller. Again, yeah, they chew food and they make it smaller. So that's a great starting point. However, let's add to that enzymes in the digestive system speed up chemical reactions in digestion to break down food. So by using this agreed vocabulary upgrade and the preemptive misconceptions, we've come up with this question, this diagnostic question, and it actually gives us so much information. What schema exists? What sort of preconceived ideas do our students have? What vocabulary do I need to upgrade? And what is the most appropriate way to explain the science behind the shift in semantics? So you might find that students have articulated a lot of this and you just need to draw a flow chart or a diagram or perhaps play some sort of simulation. You might realise that actually this will need a lot of teacher explanation alongside some sort of visual prompt. You might want to do a demonstration, a practical demonstration as well as drawing. You can really pick up the best way to deliver this information based on how the students answer the questions. Another pre-diagnostic question that I came up with was, what happens when ice melts? Some students might think the particles change shape or size, or the ice takes in the heat and the particles actually melt. Again, as before, by asking this question, we are able to see what our students know. We are able to see what language they need to be upgraded, and we can think about the most appropriate way to explain the science behind this. As I said earlier, our autonomy is so incredibly important. I'm not saying let's all meet as a science team and come up with a pre-diagnostic question and then all go and do this in the same way. Your class will benefit from your different sort of types of teaching based on the answer they give. Somebody might think this really does require a demonstration, so next lesson I'll book out the equipment. Another class might just benefit from some live modelling, drawing, whilst the teacher's explaining, and then they can move on. It will take some classes longer than others. That is okay, providing we're not spending the whole first month reteaching everything. We can spend a bit more time upgrading the language if we're not reteaching and doing all these introductory lessons. Some other ways that we could use our questioning is multiple choice. I love a multiple choice mini whiteboard question. Although it doesn't give the depth of an answer, I like the efficiency of it. So we might ask our entire class, mini whiteboard, A, B, C, or D, which of these is a feature of all living things? I'm sure we've all taught that first lesson of Mrs. Gren or Mrs. Nerg, depending which order you put your letters in the acronym. However, they have already been told that. And they also can tell you, what a mammal is specifically and go into all these different categories. So which of these is a feature of all living things? Is it A, can move from place to place? Is it B, made up of cells? C, breathe using lungs? Or D, use sunlight to make food? I would like to point out that I know that D, use sunlight to make food, is not the best, most accurate way of describing how plants carry out photosynthesis, but we're acknowledging that this is the language the students used just before they came to us, and we want to check out of these 4 options which one they think describes all living things. This is not me having got the answer wrong. This is me advising you on how to use a wrong answer. So if the majority of mini whiteboards go up and say A, can move from place to place, you've now got a really great starting point on what to do next. So they've got an animal-centric view of life. They think that all living things can move. So you now know instantly in less than a minute they've forgotten plants and fungi, potentially unaware of bacteria, but should know plants and fungi and have forgotten either that they can't move from place to place or that they are living. So we go back to scrape it back a little bit and talk about what it actually means to be living. Okay, so with our pre-diagnostic questioning, which as I said, as a team, it would be great to have searched on the Key Stage 2 national curriculum, the topic or the area that is coming up, come with your expertise as a team. In this area that's coming up, I think there'll probably be this and this misconception from the Key Stage 2 curriculum. Here are my proposed questions, and then you can all take those away once you've shared them, either mini whiteboard or ask quite open-ended. I mean, ideally, we would do both, depending on where time allows. What I will say is, if you are doing mini whiteboard questioning to help you with your planning, I recognise that doing it on the spot at the start of a lesson that you've already planned might not feel the most effective thing to do. So because it is so quick, it could be bolted onto the end of the previous topic. You might be finishing a chemistry topic and think, right, next week when I start planning biology, I'd really like to have an understanding of what the students have remembered from Key Stage 2 or what misconceptions they've got. Add 3 or 4 questions in the last 5 minutes of your lesson. Once you've packed away, mini whiteboards on the desk, and that should hopefully make it so that it's useful for your planning. Reveal the misconceptions. And again, I'm hoping the misconceptions revealed through the questioning align with the misconceptions that you collectively came up with. And then from there, you can adapt your teaching. Again, use your autonomy. Do you think this might require a demonstration? If so, absolutely do the demonstration. Does it require some teacher explanation, some live modelling? Have you got your visualizer ready or your whiteboard pens for your big whiteboard? Adapt your teaching. I'd like to encourage people to sort of veer away from the lesson plan, as it were, if you can see that your class needs you to adapt a little bit. And that is it from me. I will hand back to Constance.
Lovely. I was just going to give people a few minutes in case they'd like to submit any questions to the Q&A box. Quick question for you to begin with. You've mentioned a few times what they might have learned at Key Stage 2. So do you have any recommendations for how you handle that variation in what students will have actually covered?
Yes. So I've said this before, I sound a little bit repetitive, but I think it's really important to acknowledge that we can only do the best we can with what we're given, and we can't rewind time, go into their primary school and see what they're all doing. Unfortunately, we don't have the time to do that either. But what we can do is not reteach, not start from a blank, not start fresh. And I think it's important to know that there's going to be variation in every single class. Don't panic. Um, don't pitch to the highest, don't pitch to the lowest, just check what everybody's misconceptions are, get those mini whiteboards out. A little bit repetitive to what I said at the end of the session, but that recall, that instant recall on the mini whiteboard, it stops our students panicking that they're being tested or that they're failing, and it allows us to get an average. We can't reach the sort of needs of 30, but we can get an average and take it from there.
Yeah, that kind of mini whiteboard testing to just check for the prerequisite knowledge can be really useful.
Absolutely.
Um, I know we hear about teachers using Educate to do that, homeworks for to precede a lesson to check what needs to be covered to allow teachers time to adapt rather than feeling like they need to do it on the fly, like you were
Yeah.
saying.
Speaking of
Yeah.
on the fly, I do think that sometimes we're nervous to use our own autonomy and do something instinctively on the spot. But I would encourage if you can see actually lots of students in this class are at a completely different level to others, that's fine. Go away from what you're planning on doing when you have that realization, and do reteach. I want to make it clear, I'm not saying don't reteach anything. Just check first if it's necessary.
Yeah, great advice. I've had a couple of questions come in.
Yeah.
Um, One of the questions is, how do you get best relationships with primary schools? Do you offer CPD for primary?
So I worked at a secondary academy. I worked in a Martin secondary academy, and we invited our primary feeder science leads in. What I will acknowledge is that they were very blessed to be given the time off to come in. So I don't want to make assumptions that everyone is, but that was brilliant. They came in for an afternoon at about 2 o'clock for a couple of hours, and they looked in the students' books. They sat with us and had a chat with us. They called us out for being too simplistic. And so at one point, one of the science leads said, "What they can do more than this, and that was brilliant. Like we needed that level of challenge. So inviting your primary science leads in is a great shout. If unfortunately then unable to get the time off, can you then try and get the time off to go across to them? There's much more of them than there is of us as secondary, but at least getting 2 or 3, observe the lessons, chat. It could be as simple as swapping email addresses and having a Zoom call. Although I do feel in person, just sharing resources and books is really beneficial.
Yeah, that kind of impersonal time is invaluable, isn't it? If you can
Yeah.
get it. Also had a question about when do you suggest undertaking diagnostic assessment?
Okay, so do we mean formal or informal? I think I'll answer both, shall I? In terms of a blanket assessment to know exactly what every student knows, like on paper assessment, I'd give a couple of weeks at the start. I want the students to feel comfortable, know each other's names, know my name, know what science is, if their school called it topic. And I want to have done a little bit of recall and just maybe taught the first unit before I give them anything. Because I just think some students potentially panic when they're given a test straight away. They go home and think they're about to get moved into different sets from their friends because you've just tested them, and the score on it might make them upset because they were quite good at this at primary. And just a little bit of settling time is great. I see the benefits of these tests as well. We love data. I love data. It can be so informative, but let's let them just settle to the routine before we hit them with that. In terms of quite informal, low stakes, I do it all the time. Start of a lesson, middle of a lesson. If I think people suddenly are not focusing, am I being a bit boring? Is the challenge not enough? Mini whiteboards, I'll ask a few questions, check they've understood what I'm saying. The reason they're not listening might be because I'm saying the same thing, so let's move on. Yeah, throughout, just gauge your class.
Yeah. We've been working on some similar sort of transition, year seven transition quizzes, trying to make them really low stakes, not
Yeah.
intimidating feeling, not super long, but really targeting those areas, those threads that are foundations that are built in Key Stage 2 that you're going to want to build on. Um,
I
to
think it's
see, to help.
difficult to what you're saying. I absolutely agree with, because we do need the data, don't we, Constance? We need to know.
Yeah.
So I like the word not intimidating, or the words not intimidating. Completely agree.
Yeah. So we're releasing a few templates like that if people want to keep their eye on their inbox. This will be shared to their accounts next month, ready for use in September.
Brilliant.
I haven't had any other questions come in yet, but thank you for the ones that were submitted. Really good discussion points. Um, this has been really useful, Ashley. Thank you so much for the tips, all really practical and really useful to keep in mind. Oh, wait, hold on. One more question just before we call it quits. Do you test for substantive and working scientifically?
I think that's a really good question. Like I pointed out at the start, I think sometimes we assume students come to us being able to sort of only describe, when actually they're developing those learning scientifically skills from primary. They're using language that we probably won't use in secondary, such as, fair testing, for example. However, if we test their understanding of recording data, using apparatus, they've probably used a thermometer before. That's really useful information for us. So I would test for both. Yeah.
Yeah, those mini whiteboards are a great way to test for substantive knowledge, but I've heard a lot of teachers talk about the working scientifically can often be a really good thing to if you have the opportunity to get students to talk in conversation
Yes,
and to
Horace is
describe to
huge.
you, really test their oracy, but they also often get much better at describing and demonstrating what they know in conversation for those kinds of skills.
Yeah.
It's really useful. Right. Okay. Well, thank you so much. I'm just going to shout out a reminder that this is going to be recorded and emailed to you later. And a small request, there's going to be a very short, I think it's a 3-question survey at the end of this when you close the window. So if you could, please fill that out. It helps us know what kind of topics to cover and useful sessions to run for you. But other than that, I hope everyone has a good day and manages to find a way to stay nice and cool. Take care.
Thank you.